Okay, hi. So I'll be the representative for our group to present about the feasibility of solar panel installation in my house. These are the team members down below. Okay, first let's dive into the data. This is the data from the MEA app that I took a snapshot. As you can see on the left, it is the monthly electric bill. You can see that the baseline will be around like 10K baht per month, but it will fluctuate which is logical because some months there will be a different differentiation of the usage. Also, it correlates with the monthly electricity usage. As you can see, the trend of the graph is the same, but the unit changed from Thai baht to kilowatt hours. Uh, to mention that this data is from March to August, but in the next data, we will be looking into only September, and there will be a drastic change, which we will mention later. Okay, as you can see in this picture, it is the picture that I took at my house for 3 days, which is from 8 September till 10 September. And I'll be taking a snapshot on the evening and also in the morning at the same time each day, and I will get the number of the cumulative electricity unit usage, and I'll be using this data to project from the daily into a monthly usage of this month. Okay, as you can see, um, this is a table below that I have analyzed from the data points in the previous slides, and you can see that the daily usage compared to the nightly usage in this column. You can see that during nighttime, my house will be using around almost 4.5 times more than day. Okay, so this is the total 51, and we project it into monthly into around by timing it with 30 because 30 days, and then we get this number, and we times with 4 as the unit of Thai electricity bill, and this is where we get numbers. And if you look closely at the number right here, it says that my house is using 1.5 kilowatt hour and 6k Thai baht. But as you can see here, there's a different almost half for the Thai baht and also for the unit. This is because this is a external factor that affect it directly. Uh, I have been changing from staying at home to be at my condo, and also my brother just went back to America. So this is why the electric bill usage has changed as you compare maybe from August with September. So this is why there's a change, but we'll be only referring to September because we took the cumulative unit usage of the electricity only in September. So we'll be only focusing on this month and project this into monthly and also yearly later on. Okay, so moving on from what we analyzed about the electricity usage overview, we look into the solar panels first. So we look into the SaiMaiSolar.com, and we look into the specs, and we found out that the 18 kilowatt system is most fit with my house with my house monthly usage, which is around like uh, fluctuating around 9,000 and 12,000 Thai baht per month. So I'll be using around the midpoint, which is the 18, which I think we can talk with the contractor and then modify the size to get the specification as I calculated. And this is the cost that I projected it at. Next are the other components. So as from I mentioned earlier that the nightly usage at my house is drastically larger than the daytime. So this means that I will be needing a battery to keep the solar that I have generated during the daytime and use that at nighttime so that it will reduce the cost in the long run. So first we look into the battery. the battery I'll be using is from thaisolarpower.com. I'll be using 4 of the 14.3 kilowatt hour spec battery, which each costs around 200K, and we times that with 4, which will be getting around 0.8 million baht. Next, as we dive deeper about the battery, there's a need of a hybrid inverter from converting the electricity generated from the solar to the convention uh, 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 usage. So we will be using 2 of the 10K watt, and then we projected the price to be around as mentioned here, and this is a source if you want to refer back. Also, there will be a installation cost which we found from the greenenergythailand.com website, and we use the midpoint. So the estimated cost is around 1.53 million baht. As for the break-even analysis, this is the cost that we calculated. Also, there will be 3 saving types and each break-even point that I have came up with. So, as mentioned earlier, that the solar panel will be reducing uh, around 12,000 Thai baht per month, but this is considered at during the full peak of the sunlight hitting the solar. So this is like the optimistic optimistic approach. So we also came up with the conservative and baseline, and also the optimistic that uh, it might not reduce as 100% as we think. Yeah, so uh, these are the numbers that I came up with. So we put the cost and then divide it by the number of uh, the Thai baht that it will reduce monthly and find the amount of month. And we'll be using the baseline number as the number that we use as a metric, because the baseline is the most non-pessimistic and non-optimistic approach. And I put this into a Excel, and then I created a graph using Python, as you can see, and we'll be using this line as the 142 month as the break-even point. Okay, and on so as for this graph, the uh the the wait, okay, so for this graph we are not taking into account that the electricity fee will be rising 5% per year. So if we be using that, it will be a cumulative like curve graph. But this is we are thinking in the we are theoretically thinking that there's no change. So this is for our calculation to be easier. So this is a footnote. Okay, thank you.